Welcome everyone. Today is Wednesday, the 12th of August, 2026, and this is the Cluster API office hours. Cluster API is a subproject of Kubernetes, and as such, we follow their meeting guidelines, which can be summarized as please be excellent to each other, and if you'd like to talk, please raise your hand. All right. Usually we welcome new attendees, but I think it's just the four of us, and we've been here before, so we'll skip that. No open proposal readouts, I don't think. Unless I think we still have a week to go on on our on our lazy consensus for this one. But yeah, Richard, I see you have your hand up, please.
Yeah, I added a new one today, which is that second one, the manifest publishing via OCI. Something I've been meaning to do for a while, but essentially that is just taking the manifests for the various providers, core CAPI and the KubeADM providers in this instance, and publishing them as OCI images. Idea being, well, I guess two main use cases. One is to enable GitOps easily with CAPI operator and Fox and Argo. So you've got the manifest and obviously the image, that's all good. Air gapping as well, so you can easily, just call the imagery tag and stick it into your own registry, which is kind of a gap at the moment. And cluster couple, sorry, I had a blank there. And obviously supporting OCI images in cluster couple instead of just putting them from Git Hub or GitLab. But that covers those use cases. What it doesn't cover is a raw apply using GitOps, so using Flux or Argo, because that does then start to involve using, potentially changing the templating that we use because they don't not necessarily support the flavor of end subs that we use. So this deliberately doesn't cover that and says that's future work, but yeah, that's just a new one.
Cool. Yeah, thanks. I just saw the email about this morning. I queued it up for a read after lunch, so I'll be getting into that. But yeah, thank you. And then I think I'm trying to remember, did we put a lazy consensus on this one, I think, for another, so like,
Yes, we did.
yeah, okay, so we still have 1 week to go before we merge that. Okay, great. All right, there's no discussion topics unless someone wants to add something now, I guess. I've got a provider update. I released a new version of KubeMark, just updating to some older versions of CAPI. Yeah, and I'll probably work on another one, soon for 1.13. Okay, does anybody have ad hoc topics they want to bring up, or should we just call it a meeting here and make it a simple one? Going once? Going twice? Okay, another record short meeting. Oh, Stefan. What would you like to talk about, Stefan?
Just a heads up. Basically, I'm working on some scale improvement for core copy. We've been running some scale tests, and what we realized is that one big reason why we're taking a lot of memory is that we're using a lot of unstructured, and primarily from a lot of machines. So we sort of scale testing with a little bit of a random cluster sizing of like one cluster, 27 machines or something. And a huge amount of memory is basically unstructured bootstrap configs in infra machines. So I'm working on a PR, which is rather big, that tries to fix all of that up based on my scale test on like the same sizing that I just mentioned. That PR reduces KSP memory usage by 25% and core copy memory usage by 45%. So just a heads up, because it's a big PR, and depending on what people are doing, they might have to, depending on merge order, but they might have to rebase. The high level idea on what I'm trying to fix is the following. Basically, instead of using unstructured, I'm using Go types to cache bootstrap configs in infra machines. You might want to think like, how? Basically, we have a contract. The contract describes which fields you're supposed to have in a beta 1 object or in a beta 2 object. So I'm just creating Go types that look exactly like that. And then whenever I see a machine and want to get the corresponding booster configured for a machine, I dynamically spin up a new cache, register the special type in that cache, and then create an informer for that. And then that requires like changes in the machine controller, machine set controller, machine pool controller in a bunch of places. But looks good now. I mentioned that I'm dynamically creating a cache. The reason for that is basically that when you create an informer, the type has to be in the scheme. But you cannot mutate the scheme at runtime because you basically get a concurrent read-write map whatever access out of the runtime scheme. That's not good. So I have to do this all sort of like dynamically because when the controller starts, I don't know like which info machines or bootleg configs I'm going to find. I don't know how many of those like booster configs of or info machines of different providers I'm going to encounter. So I basically have to do this all dynamically instead of just using the one scheme and the one cache that is like in like the main scheme and the main cache that is inside the control runtime manager. And now that I have a util that allows me to dynamically spin up caches, I can basically also do something like when the KCP controller sees an infra machine, I can basically give the informer for the infra machine a specific cache configuration. That has the same limitation as like the scheme thingy. So basically when KCP starts up, I can give it one cache config at startup, but then later it's like immutable. I mean, the reason why it's immutable is because control runtime takes that cache configuration once. It creates the caches like at startup, and then that's it. You cannot like mess with that later. And what I want to do is when KCP starts and it sees like an infra machine, let's say a vSphere machine, then I want to say like, oh, I do a get vSphere machine that creates an informer in the background, and I want to give that a specific cache configuration. But I want to basically have to connect like the vSphere machine GVK with that cache config, and I cannot do that at KSP startup because when KSP starts up, it doesn't even know that it's going to see like a vSphere machine later. And the big improvement there is essentially that with that customized cache configuration in KCP, I'm basically stopping to cache worker infra machines in KCP, and I'm stopping to cache infra machine templates that also belong to workers because KSP doesn't care about them. It just didn't have a way to not cache them before. Yeah, so that's in flight. I'm around like 5K lines of code at the moment. I think I'm almost done. Looking forward to Fabrizio being back so we can review this thing. But it's not super crazy complicated. It's just a util that basically creates a cache when I do a get call, makes sure that those caches are not like basically shared across get calls. And then I had to change a bunch of places to actually use the new util. I think it's probably not really applicable for info providers because the main problem is that core copy has to work with unstructured, that it has to work with types that it never saw before. And then it's the high granularity of bootstrap configs and infra machines. I assume that info providers usually don't have that problem because they're just working with their own stuff, of which they have the types, or they work with core copy types, of which they have the types. And then it's all much easier.
Yeah, I echo what Nolan and Richard are saying in chat here. It sounds very cool and it also sounds complicated to me. But this
I
does
think
make
that
me wonder though, for the cluster autoscaler, we make heavy use of unstructured there. And I wonder if I might be able, like, I don't think we need to change the informer caches in the same way that you're doing for like KCP and whatnot, but like, it makes me wonder if we should maybe think about migrating the cluster autoscaler to not use unstructured and to, to vendor some version of the API, even though that's going to tie us, more heavily to cluster API.
yeah, I think there are. So I mean, first of all, I think you have a bit of a different deployment topology in the sense of that. I mean, there are different variants, right?
Right, exactly. It's
But
not
in,
the
in
same
some of
problem.
in some of that variants, basically, you only care about like one cluster in one namespace or something. And in that case, I would already try to only watch that namespace, and I'm not sure if that's how the cluster autoscaler works or not. But then in the other case, I think where it's like you can also deploy it on a management cluster and then it's watching everything. I think definitely there at scale you reach like the scale where it makes sense to think about this.
Okay.
It could be that you don't actually have to vendor some version of our APIs. You can also, I mean, from like a coupling point of view, it's basically equivalent if you either use unstructured or use a Go type that contains the fields that you're trying to read out of the unstructured. There's not much difference there.
Okay.
Yeah, so you can basically, what you can do is you can sort of try to build your own, I mean, whatever you're reading, right? Machine deployed machine set types with the subset of the fields that you care about. And then you only use those for your informer. And that's it. So you have the same coupling as today. You depend on this object being there, having certain fields, which you already do. And then you have an informer for it. The very nice thing is basically, oh my God, I think I basically missed like almost the biggest. So there are two improvements from using a specific type instead of unstructured. One is you stop using unstructured, and unstructured is inefficient. But the other one is if I'm caching like a bootstrap config or if I'm caching an infra machine, probably more a bootstrap config, there's a lot of data in there that Copy never cares about. And in my type, they're not there, right? So in my type, a bootstrap config has maybe 10 or 15 fields, and that's it. In unstructured, it has everything that is in there. So that's like the other part why it's much less memory usage. One, because it's a specific Go type instead of unstructured, and the other one is it only contains the fields that I care about. And you would basically also get both improvements if you follow that pattern in Autoscaler. What you probably have to do, the way the stuff works is you probably have to create like your own, let's make an example, machine deployment type. And then I think I don't know if you can use controller runtime in cluster autoscaler, but if you cannot, then you probably have to generate an informer based on that type.
Yeah.
Just like how people generate informers of all the other stuff as well.
Yeah.
I'm not aware of any additional problems there, but it's a bit different on how it's implemented.
Now you're kind of blowing my mind with the like constructing types that have like a limited subset of what because I guess like at some level you're just unmarshalling JSON. And if
Yes.
you've got a type that only wants a subset of the information, it just drops the rest of it and unmarshals
Yes.
what you want, right?
Yes. Yeah. I even went as far as like unmarshalling conditions and only keeping the one condition I care about.
Right. Like, because the cluster autoscaler only cares about a few things, right? It only cares about like replicas and like a couple other things. There's probably a way that we could like limit like a lot of the extra usage there.
Yeah, exactly. If your Go type only has the fields that you care about, everything else just gets dropped during unmarshal and not permanently stored in the informer.
Yeah, that's very cool. I appreciate you sharing all this with us. This is really awesome. This is the pill you're working on now?
Yeah. Yeah.
Okay, cool.
I link it in the channel point that you added. Thanks for that.
Yeah, that's awesome. Cool. Like I realize it's still work in progress, but I'll probably take a look just to get some ideas and everything.
Yeah.
So
the reason why it's a work in progress is basically because I just got to the point where like the only remaining step is that I'm going to review this PR by myself.
okay.
Which does not mean that this is entirely AI generated. It's only like 5% of the unit test is AI generated. But I usually like to review PRs that I'm putting up myself at the end, just so they have like already pretty high quality before someone else has to review a PR of that size.
Yeah,
So
cool.
it's already pretty good, but there might be like another 1 or 2% changes or something once I'm done with reviewing it myself.
All right. I mean, I think that sounds awesome. And like, yeah, I'm probably going to take a look and just out of curiosity. So appreciate it.
No problem.
Okay. So we're not going to have the shortest meeting ever now, but we had a good discussion there. So does anybody else have topics that they would like to bring up before we go here? Going once? Going twice? All right. Let's call it a meeting. And thanks everybody for coming out. And yeah, we'll see you next time.
So, bye-bye.
Yeah, later.